Moving on with what we left yesterday, I think the problem that we were yet to do was, this was left out, x square y dash equal to y minus x minus 1. You know? Okay. Uh, to find the solution for this equation, I think let's start with that. I say let y equal to summation Cn xn and from 0 to infinity be a solution which is nothing but C0 plus C1x plus C2x square. In the beginning, if you have problems, you can just expand the terms and then work on it. Okay. So if I take this as y Cn x to the power n minus 1, but n varying from 1 to infinity, which will make it nothing but C1 plus 2C2x plus 3C3x square and so on and so forth. Okay. So when you substitute in your differential equation, you know, the values of y dash and all, I think you can do it simultaneously. Okay. So what you are going to get is x square summation n Cn xn minus 1 n from 1 to infinity equal to, okay, I'm writing it like this, minus 1 minus x plus summation Cn xn n from 0 to infinity, right? So which means, now this term would mean summation n from 1 to infinity n Cn. Now this will be x to the power n plus 1, which will be equal to minus 1 minus x plus summation Cn x to the power n from 0 to infinity. Okay, now see, in this case, you have the presence of these two extra terms. See, had it been only summations, we have had no problem so far, right? But in this case, we have the presence of this term and this term. So what is this term? This is a constant term and this is a term containing x. And what we observe is that even from this infinite series or this infinite series, we are going to get constant terms and terms containing x. Okay, so that means if I have to compare the coefficients, then I have to, sort of take out the constant and the term containing x from both the infinite series and then write the remaining terms in terms of infinite summation. Okay, so that means if I just look at my first term, first term is going to be like your n is starting from 1. So it's going to be C1x square. This is what is the first term you are going to get. Am I right or wrong?
Yes, ma'am.
If you expand the series, right? So that means basically what this term is going to give me an idea is that the left-hand side is not going to contain any term which is constant or containing x. Okay. Whereas if I look at my right-hand side, this is again as so on and so forth, 1 minus x plus, if I just write, I'm going to get C naught plus C1x from there. Okay, and then the remaining I can write Cn xn n from 2 to infinity. Is that right? What was your left-hand side? There is no term containing a constant term. There is no term containing x. But your left-hand side is actually n Cn x to the power n plus 1, where your n is starting from 1 to infinity. Okay, and this is equal to this. So that means actually this is equal to, I can combine these terms as minus 1 plus C naught if I collect the constant terms, and if I collect the terms containing x, it's going to be C1 minus 1 from here and here, and plus I'm going to get terms like this. Is this clear or not?
Yes, ma'am.
Okay. Now see, as I was saying in the beginning only, we have to now combine these two summations, right? Whether you look at this perspective or you look at this perspective, you are going to get the same things, in the sense that, as I said, the best thing is keep in mind that I want x to the power n here. So if I want x to the power n here, what do I want? I want to change this n plus 1. So basically, what do I want? I want to change my n to n minus 1. Minus 1, this term will become n, right? But then what are you doing? You are actually decreasing your summation index. Now, if you are decreasing your index, that means you have to increase your starting point. Okay, so if you change your n to n minus 1, that means your left hand side can be written as n minus 1, c n minus 1, x to the power n, but n from 2 to infinity, because I will then change my I will increase my starting point. See, this is the logic that you have to remember. Whether you are increasing your index or decreasing your index. Okay, accordingly, you will be either decreasing your starting point or increasing your starting point. So basically, your series then gets reduced to something like minus 1 plus c naught plus x into c1 minus 1 plus summation n from 2 to infinity cn xn. Now you can combine both these terms, and accordingly, what you get is that, okay, what I can write now is I will have minus 1, sorry, what was, I'm now trying to combine the terms here. So minus 1 plus C naught plus x into C1 minus 1 plus summation Cn xn, n from 2 to infinity, and I bring the left hand side here. So it's n from 2 to infinity, but I have n minus 1 Cn minus 1 x to the power n equal to 0. Is that right, whatever I have written? हाँ, कोई कुछ गलत तो नहीं लिखा? प्लस माइनस प्लीज क्रॉस चेक. Plus summation x to the power n into Cn minus n minus 1 Cn minus 1, n from 2 to infinity is equal to 0. Now, is it clear till now? If you have any query, please ask. Is it okay or not? Bolo?
Yes, ma'am.
Yes, ma'am, clear.
Clear.
Yes, ma'am.
Okay, so we can move ahead. Now you can equate the coefficients to 0. So what do you get? That means you get C naught equal to 1 from here. यही आ रहा है ना? You'll equate that this term to 0. Then you equate C1 minus 1 equal to 0. You get C1 is equal to 1. And from here, you are going to get Cn is equal to n minus 1 Cn minus 1 for every n more than or equal to 2, because this summation is starting from n equal to 2. Okay, so that means for n equal to 0, we have this. For n equal to 1, we have this. And for n more than or equal to 2, we have this recurrence relation. Okay, so if you use this recurrence relation, you get C2. When you put n equal to 2 here, you get C2 equal to C1, which is 1. Right? Then similarly, C3. C3 is equal to what? 2C2. And how much is C2? 1. That means C3 is 2. Similarly, C4. C4 will be 3C3. And how much is C3? 2. So basically, this is nothing but 3 into 2. Similarly, what will be C5? 4C4. So this will be what? 4 into 3 into 2. Do you get anything?
Ma'am, Cn is n minus 1 factorial.
Cn is n minus 1 factorial for every n more than or equal to 2. So you have C0 1, C1 1, and Cn equal to n minus 1 factorial for every n more than or equal to 2. Is that okay? So basically, what is your y now? 1 plus x plus, what was C2? 1 only, so x square. What was C3? 2x cube, or they can say 2 factorial x cube, 3 factorial x to the power 4, 4 factorial x to the power 5, and so on and so forth. Okay, na? Plus x plus summation n minus 1 factorial x to the power n from 2 to infinity. I can write it like this. You know? So can you not compute your row now? एक बारी फटाफट, quickly, can you compute the row, the radius of curvature, so that we know when the series converge? How much is rho?
Ma'am, 0.
0.
0.
Yeah, because it must be turning out to be limit n tending to infinity 1 by n. ये आ रहा?
Yes, ma'am.
Minus 1
Yes,
factorial
ma'am.
upon n factorial, right? So it turns out to be 0. So what does this mean? This means what happens when rho is 0?
And the series diverges for all x not equal to 0.
The series diverges, or the series is convergent only when x is 0. But when x is 0, what happens to this? What is the term that you get? Only this, y equal to 1. So basically, this means that this differential equation does not have a convergent power series solution. The series is diverging. This solution has no meaning. Are you getting the point now? So that's why convergence is important. That's why we wanted to specify the other day also, because, okay, this is all what we are doing right now is we are actually computing things and then trying to see what is happening to the power series. Okay, so it's like if we are finding the solution first and then we are testing whether the series is convergent or divergent or whatever is happening to it, right? Whereas, ideally speaking, it should be done before. I mean, we should, looking at the differential equation, we should know whether this differential equation is going to have a convergent power series solution or not. Ideal situation is that, right? So gradually we are going to come to that only. We are just building the theory. What we are doing right now is we are just coming across various options, you know, where we can end up with, whether we have seen all types of series. We have seen a differential which will always have a convergent series solution. We have seen a differential equation which will have a convergent series solution, but when x lies between certain specific quantities, like -3 to 3, right? We have seen the third kind of a differential equation which does not have a convergent power series solution. Okay, so these are the various situations we can end up with. Is that clear?
Yes, ma'am.
Yes, ma'am.
Now see, things were simple when we just had a first order differential equation kind of a thing. What if we have a higher order differential equation? Okay, in the sense that, say, supposing I have a second order differential equation, then how to move about with it? We can do one thing. Let's try this question number 11 of your exercise. Okay, I'm not doing the solved example right now. That you can try later on your own. Once you know this, this is your question number 11 of 8.1. Okay, y double dash equal to y. Now it's the second order differential equation. Okay. And you know how to solve it. I mean, from the normal methods, the existing methods, we know how to write this. Now it's a second order differential equation with constant coefficient. So your complementary function itself will be the solution because there is no right hand side. To find the complementary function, what do? You find the auxiliary equation, equate that to 0, you find the roots, and accordingly we write the solution. All this we have learned. I'm not going into those details. Now we are just going to see how does the power series solution for this kind of a problem starts with. Okay. Now again, the process is the same. I'll start with y equal to summation Cn xn n from 0 to infinity. So your y dash, let of course this be a solution. I'm not writing that, right? So your y dash will be n Cn x n minus 1, but n from 1 to infinity. And what will be your y double dash? Now see, because we are going to have these kinds of summations. So your y double dash will be n minus 1 Cn x n minus 2. Are you girls doing it simultaneously? Because if you
Yes,
do,
ma'am.
Yes, ma'am.
because if you do it, it will be better for you all. Okay. Now, once we have this, obviously we substitute in the differential equation and we get summation. It should be n minus 1 Cn x n minus 2 n from 2 to infinity. This was y double dash, and the equation was y double dash equal to y, which means y double dash minus y equal to 0. So I can write it as minus. So there is no y dash, so no need to write that term. So it will be this, n from 0 to infinity equal to 0. Now see, as again I was saying earlier, now we want to combine these two summations anyway. This is starting from 0, this is starting from 2. Here I have xn, here I have xn minus 2. So I need to change this n minus 2. So what I can do is, I can change my n to n plus 2 in the first summation. The moment you change n to n plus 2, your starting point, see, you have written n plus, your starting point reduces. Okay, so that means my left hand side will now become summation n from 0 to infinity, because I have increased the index by 2, therefore the starting point will reduce by 2. Okay, so when your starting point reduces by 2, it simply becomes 0 to infinity, and I'm going to have n plus 2 because I've changed my n to n plus 2, and n minus 1 will become n plus 1 C n plus 2 x to the power n. Is this clear how I am doing it?
Yes, ma'am.
Yes,
Okay.
ma'am.
And the next term remains as it is. So as I was saying, this will come automatically. Okay. So that means now I can combine both these summations here, because now my index, my starting point for both the summations is 0, and I have x to the power n in both the terms. हाँ जी,
मैम
बोलो.
सेकंड टर्म में वहाँ पर n नहीं आएगा ना, Cn के साथ.
Oh, sorry. I'm sorry. Yes. You're right. Okay. It was simply y, right? So now I take x to the power n, and my coefficients now are n plus 2, n plus 1, c n plus 2 minus cn equal to 0. Is that right? Right. And so what do you get? The recurrence relation.
Cn plus 2 equals Cn by n plus 2 n plus 1.
Yeah. Is it Cn plus 2 ही आ रहा ना? Right. Because I'm changing my n to, yeah. So what I'm getting is that Cn plus 2 is equal to Cn upon n plus 1 into n plus 2. यही आ रहा ना?
Yes, ma'am.
Right. Now you can proceed on. So for n equal to 2, now see, it is a second order differential equations. So how many arbitrary constants should it have?
2.
2. So that means we should also get 2 constants. And like in the first order differential equations, we have seen that the constants that we were getting were what? C naught ही आ रहा था सब में, the first term, so that every other coefficient could be expressed in terms of C naught. So in this case, since I am going to get 2 arbitrary constants, so somewhere down the line, my intuition says that my constant should be C0 and C1. Okay, so let's see what actually happens. So when n is 2, when n is 0, what do you get? C2 equal to C0 upon 1 into 2. This is what you get. What happens when n is 1? You're going to get something for 3. And what will be that? C1 upon... okay, let me write it as 2 into 3. Is that right?
Yes, ma'am.
What happens when n is 2? Write at least 5, 6 terms. So when n is 2, what do you get? C4. C4 is equal to what? C2 upon 3 into 4. But how much is C2? So that means what you get? C0 upon, I can write it as 4 into 3 into 2 into 1. Can I write it like this?
Yes, ma'am.
Now, what happens when n is 3? Nikalo apne aap. I'll do it for... oh. What happens when n is 3?
C1 by 5 into 4 into 3 into 2 into 1.
C1 by 5 into 4 into 3 into 2 into 1. Right? Can you write your C6 without using the recurrence relation? Okay, what do you observe?
Ma'am, there is not by n factorial in even terms and C and in odd terms there is C1 by n factorial.
Not n factorial, तो नहीं बोलेंगे उसको, because we are differentiating in terms of odd and even. See, what is happening? All your odd terms are in terms of C1 and all your even terms are in terms of C0. So how do you write odd and even? We express in terms of C2n and C2n plus 1. इसी तरह से ही करते हैं ना, because see, it's you do not say Cn when n is odd or Cn when n is even. We say Cn for all n's. Okay, so to make it odd or even, we have to make it odd or even here, because your n will start from 0. Because you see, your series is this, which you have taken as your summation, and which you have taken as your solution. So you cannot differentiate here whether n is odd or even. It's just that we have to identify what happens when n is odd and what happens when n is even. And the general terms for odd and even are what? 2n and 2n plus 1. Okay, my n can be anything in that case. So for n to be anything, I know 2n will always be odd, even. So for n to be anything, 2n plus 1 will always be odd. Okay, so one thing is clear, that C2n for all odd terms, it's going to be C0 upon 2n factorial. Yahi aa raha hai na? Because when n is 0, I'm sorry, this is 0 and 1, and this is going to take place for every n more than or equal to 2. What happens when n is 1? Sorry, forget it. You have C0, you have C1. Okay, when you have to compute C2, so what happens when n is 1? You get C2. So C2, 2 factorial. Yahi aa raha tha. C3, you had 3 factorial. C4 will have 4 factorial. So basically this is nothing but these terms that you are getting. Is this clear or not? If you
Yes.
write
Yes.
the series now, that means your y is now, your solution by x is now going to be C naught plus C1x, yahi aa raha tha na? Plus C2x square. But C2x square will be what? C naught x square by 2 factorial plus C3. C3x cube. So C3 will be what? C1 by 3 factorial x cube plus C4 by 4 factorial x to the power 4. Oh, sorry, C naught by 4 factorial x to the power 4 and so on and so forth. So when you, just a minute, when you write this solution, you are going to get something like, the solution that you are going to get something like C naught in 1 plus all even terms will be here, something like this, plus C1 into and all odd terms, that means x plus x cube by 3 factorial plus x5 by 5 factorial and so on and so forth. Is this correct or not? Bolo. Any doubts, please, because these kind of differential equations are pretty important. Is this okay or not?
Excuse me, ma'am.
Bolo.
Ma'am, can you repeat the nth? How we managed to find the nth term? Like
Okay.
C2 in.
See, what we observed was that we had C naught and C1, right? But we observed was C2 कितना आया था? C0 by 2 factorial, right? C3 कितना आया? C1 by 3 factorial, right? C4 कितना आया था? Ultimately, C naught by 4 factorial. यही आ रहा था ना?
Yes, ma'am.
How much was C5? Again, C1 by 5 factorial and so on and so forth. What we observed was that the terms, the coefficients, behaved differently for odd terms and for even terms, right? But when we have to generalize, I mean, I cannot say Cn, right? Because my n will vary. So instead of saying Cn is C naught by n factorial when n is odd, or Cn when n is even, and Cn is C1 by n factorial when n is odd, we do not say like that. We do not say like that. Just a minute, girls. So since we cannot write it like this, why? Because when we are talking of terms in, when we are talking of things in terms of n, that means it is my n which will vary from 0, 1, 2 and so on and so forth. I cannot specify n is odd or n is even. So to overcome that, for every, you can say, whole number n, or for every counting number n, how do you write when it is even? When it is of the form 2n. And how do you write when it is odd? When it is of the form 2n plus 1. So instead of writing Cn when n is even or Cn when n is odd, we write in terms of, that means we just explain things, what happens in this and in this scenario. Is this clear now? See, ultimately,
Yes, ma'am.
or your n will vary from 0, 1, 2 and so on and so forth. So when n is 0, in both the cases we have C0. But what happens when n is 1? So you are getting C2, C3. Okay, so for both the terms, whether it's odd or it's even, you are getting the coefficients when n is 1. Similarly, what happens when n is 2? You are getting 4 and 5. So basically था यही. See, for all even terms, it was C naught upon a factorial किसका था? For C2, it was 2 factorial. For C4, it was 4 factorial. So what should it be? Simply 2n factorial. Similarly, it was Cn upon 2n plus 1 factorial. Is this okay?
Yes, ma'am. Yes, ma'am.
So that's how you are getting your series. Now, this particular case, I don't know whether you are familiar with it or not, but I think the first term which you have, see, had it been alternately, I mean, just look at that series. Does it look familiar?
Cos hyperbolic.
It is cos hyperbolic x. For the series on cos x, the terms are alternately plus minus, right? But in this case, you have all terms with a positive sign. So it is a series for cos hyperbolic x, and the other one is a series for sine hyperbolic x. So you have to, that means what? See, the moment you are able to express it in terms of some function, of course, you might not be able to do it for every such solution. But one thing is very clear, that whatever power series we had, it is a convergent power series, number one. And secondly, it converges to this function, cos hyperbolic x. Similarly, the second series, it also is a convergent power series, and it converges to this. So basically, what have you got? You've got the same logic back, in the sense that it is a second order differential equation. So it must have two linearly independent solutions. And what are those linearly independent solutions? y1x and y2x. And how do you get the complete solution? A y1x plus b y2x. This is your complete solution. And this is what we have got. So basically, we have two independent power series, okay? One representing cos hyperbolic x, the other representing sine hyperbolic x, and their combination is the complete solution of the given differential equation. So as you can see, it is a second order differential equation, so it has two arbitrary constants, C0 and C1. Is this clear?
Yes, ma'am.
Okay, if it's clear, just try the another one. I mean, this is, shall we try this? Yes, this is also simple. Try the 13th problem, okay? It's y double dash plus 9y equal to 0.
Ma'am, here, ma'am, in the 11th question, do we need to find the radius of convergence or just write these are convergent series?
Yeah, in the exercise it says yes, so you can always find that.
So, ma'am, we need to find it independently for C2n and C2n plus 1.
Yes, you can do that. Yes.
Okay, ma'am.
See, but then when you are writing the two successive terms, see, if you take the nth term, if it is odd, then the next term will be even. And if it is even, then the next term will be odd. See, what does radius of convergence say? It is a ratio of the coefficients of two successive terms.
Yes, ma'am.
Right? So when it is odd, when it is even, then you have to be careful which term you are taking in the numerator, odd or even, then the denominator will be different. Are you getting the point?
Yes, ma'am.
Right?
Yes.
So accordingly, then find rho.
Okay, ma'am.
Okay. Now, similarly, see, let's try this. Now, of course, these equations must be familiar to you because you've solved them by the other method, by finding their auxiliary equation, finding the roots, and then writing the complete solution. So this is also something like that, right? So now if you have to solve this differential equation, so then again, just try doing it. Your y remains the same, n from 0 to infinity. Your y dash becomes n cn x n minus 1, n from 1 to infinity. Your y double dash becomes n minus 1 cn x n minus 2, n from 2 to infinity. And when you substitute here, you are going to get summation n n minus 1 Cn x n minus 2 n from 2 to infinity plus 9 summation Cn xn n from 0 to infinity equal to 0. So it's exactly similar. We have to make this xn. Okay, so what do? You will change your n to n plus 2 and your starting point will change from 2 to 0. So what you are going to get now is summation n from 0 to infinity. क्या आ जाएगा यहाँ पे? n plus 2, n plus 1, c n plus 2 xn plus 9 summation c n xn equal to 0. But again, n from 0 to infinity. So basically you are getting summation n from 0 to infinity xn into n plus 2, n plus 1, cn plus 2 plus 9cn equal to 0. So accordingly, you will get your cn plus 2 will be what? Minus 9 upon n plus 1 into n plus 2 cn, right? So now, just like the previous, now it is absolutely similar to the previous problem. Will you be able to complete it now?
Yes, ma'am.
Yes, ma'am.
Again, you will get different terms when for or, different for even. So, and that I have already told you how to write that, right? But see, look at the 14th problem. Yes. In this case, what you have is, I'm leaving the earlier problem for you to complete. Will you be able to do? हो जाएगा ना सबसे?
Yes, ma'am.
Right.
Ma'am.
So let's look at the 14th problem now. Okay. It's now y double dash plus y equal to x. Now specifically I have taken up this because there is a term containing x now. Okay. So I think you faced similar kind of a problem in the previous set of questions also. Okay. See how we handle this is, again, I'm not writing everything, but yes, see, even till I have to write this because otherwise I'm not very clear about the indices and the powers. Cn x n minus 2 and n from 2 to infinity. And when I substitute in this differential equation, I get summation n from 2 to infinity n minus 1 Cn x n minus 2 plus y, which means summation Cn xn n from 0 to infinity and minus x equal to 0. Right? Now, the moment we have this, now see what happens is that I have this extra term that contains x, right? So even if I try to, combine these summations here, it's not going to help me out because I'll still have this term containing x with me. And somehow, even from this series, I'm going to get terms containing x, right? Similarly, from this series also, I'm going to get terms containing x. Okay, so that means what I can do is maybe I can write a few terms in the beginning, few terms till I get terms containing x, and the remaining I generalize in terms of an infinite series. Okay, like from the first term, when n is 2, what is the first term you get? When n is 2, you are going to get 2c2. That's it. This is the first term that you are going to get when n is 2. Your summation is starting from n equal to 2. So that means the very first value of n that we can substitute in that summation is n2, right? So, and when I put n equal to 2, I'm going to get this because the first term is going to be x to the power n minus 2, which means x to the power 2 minus 2, which is constant, right? What when n is 3? You are going to get 3 into 2, which is 6 C3x. That's it. And this is what I wanted. I wanted term containing x because I want to club it with an already existing term, right? Now, what I do is the remaining I write in the series. But then what has happened? I have already taken out the term when n is 2, when n is 3. That means now my summation you should start from n equal to 4 because 2, 3 I've already written. And the remaining generalized terms are this only. Is that okay? Is this
Yes,
clear
ma'am.
or not?
Yes, ma'am.
Right.
Yes, ma'am.
Similarly, from the second summation now, I write it again C0 plus C1x. These are the two terms containing x. The remaining I write as Cn but now my n will start from 2 to infinity. Is this okay? Then minus x equal to 0. I have just rewritten my terms. Is that okay?
Yes, ma'am.
Now, that means if I now collect the terms, I'm going to get the constant terms as simply 2c2 plus c0. Then with terms containing x, I'm going to have 6c3 plus c1 minus 1. Right? Because I have now 3 terms containing x. Okay? Plus summation n from 4 to infinity n minus 1 cn xn minus 2 plus summation cn xn n from 2 to infinity equal to 0. Is this okay?
Yes, ma'am.
Fine. Now see, I have 2 options with me. If I just look at this, I can have the summation for both of them. I can have starting from 2 to infinity, both of them, or I can have both of them starting from 4 to infinity. If I want the summation to start from 2 to infinity, I need not change this term, but I will have to change this term. Okay? And if I want to start from n equal to 4 to infinity, I don't have to change this term, but I will have to change this term. Okay. So let us start with 2 to infinity because this is a comfortable term. So if I want to start my n from 2 to infinity, that means I have to change it here. That means I want to decrease the starting point. So if you want to decrease the starting point, we'll have to change my n to n plus 2 in this term. The moment you change n to n plus 2, just a minute, I'll write it again. So that means I'm going to get my first term will still be this 2c2 plus c0. My second term will still be this 6c3 plus c1 minus 1. But my this summation will now change from 2 to infinity, and instead of just a minute, let me check it. Yeah, I had x to the power n minus 2, so I'm changing n to n plus 2, so I will have x to the power n. And since I have changed n to n plus 2, so I'm going to have, I'm sorry, I have to refer back, n plus 2 into n plus 1. Yeah, aega na? n plus 2, n plus 1, c n plus 2. Is that right? गलत तो नहीं लिखा मैंने?
Yes, ma'am.
We've changed n to n plus 2 in this term. And the second one remains as it is, plus summation n from 2 to infinity cn xn equal to 0. So basically what you get is 2c2 plus c0 plus x into 6c3 plus c1 minus 1 plus summation n from 2 to infinity x to the power n into n plus 1, n plus 2, cn plus 2 plus cn equal to 0. Okay, so now you can equate each of term, and what you are getting now is you are going to get the first term will give you that 2c2 plus c0 is equal to 0, which means c2 is equal to minus c0 by 2. यही आएगा ना? Similarly, the second term is going to give you c3 plus c1 minus 1 equal to 0, which means c3 is equal to c1 minus 1 by 6, which I can write as minus of 1 minus c1 by 6. Okay, and what you are going to get from the second term is the fact that the last term is that cn plus 2 is equal to minus 1 upon n plus 1 n plus 2 cn, but for every n more than or equal to 2.
Ma'am, C3 will be 1 minus C1 or C1 minus 1.
Now,
Yes, ma'am.
wait, just let me check. It was 6c3 plus c1 minus 1 equal to 0, na?
Yes, and so the answer should be C3 is equal to 1 minus C1 by 6.
Oh, okay. So I'm writing it as minus of c1 minus 1 by 6. Ab theek hai?
Yes, ma'am.
Right. Okay. And cn plus 2 will be this.
Yes, ma'am.
For every n more than or equal to 2. Right. So now when you put n equal to 2, because this recurrence relation works for every n more than or equal to 2. So when you put n equal to 2, what do you get? C4. C4 is how much? Minus 1 upon 2 plus 1, 3 into 4. C2. And how much is C2? So this becomes minus minus plus, and this becomes C0 upon 4 into 3 into 2. Am I right? Which is actually nothing but C0 upon 4 factorial. Right? Similarly, when n is 3, you get C5. C5 will be how much? Minus 1 upon 3 plus 1, 4 into 5 into C3. But C3 is this, right? So your C5 is going to be minus into minus plus. So it's going to be 1 upon 6 into 5 into 4 into C1 minus 1. So that means all your odd terms will have C1 minus 1 and all your even terms will have C0. Will you be able to complete it now?
Yes, ma'am.
Okay. So I'll just end up here today. And so that